Alright, today we're going to talk about deriving equivalent equations through factoring or completing the square. So we've done these skills before. We're going to talk about a concept of equal things or having equality. Okay, so for example, I know what I'm going to do. Let's have you three stand up. And then you three stand up. Okay, so I'm going to pull up these 6 students up here. Okay, so right now I have 6 students up here. They're all standing in random order. Okay, I got a girl plus a boy plus a boy plus a boy plus a girl, right? Does it make sense? Okay. Now I could factor or break it apart, finding common factors, right? What's a common factor I could break apart? Well, I could break apart all the boys together into two different groups. So I'll put all the boys on that side, so all the boys go to that side, and then all the girls come over here and stand in 2 different groups. Did I change how many students are up here?
No.
No. Isn't that the same students up here?
Yeah.
Does that make sense? But I've also factored it differently, right? Okay. So, or another way I could do is like long hair and short hair. So, Patrick, you're long hair. Come over here.
I am.
Yeah, you're long hair. Okay.
Just kidding.
If you have longer hair than me, you have long hair.
Okay, so those.
Okay, so short hair plus all the long hair people. Different factors, right? Did I change the type of people up here? No, they're the same people. Does that make sense? Right? So we factored them similarly. Okay? So it's equivalent. Same people, they still equal the same amount of people, same amount of names, same amount of personalities. We just grouped them differently, factored them differently. And that's what we're going to do today. That's the concept, okay? Go sit down. Let's give them a hand. Being themselves. Okay, here we go. So here's steps for today. We wrote them down already, but if you're on the video, you should pause and pause and write them down. Here we go. I'll do number 1 and 2. Now number 1 and 2, look at numbers 1 and 2. They're both the same, okay? So I'm going to show you how to do 2 different kinds of equivalent equations doing the same methods we used to do. Okay, so just watch right now. Okay, so there's 2 ways you could do this. You could either do this X box or complete the square. So the first way I'm going to do it is, remember when we used to do X box, we have to figure out what A, B, and C are. So, and then we draw an X box. You know, A is 1, A is 1. A times C is negative 35. And then B is negative 2. And then we have to figure out what times what equals to negative 35, but adds up to negative 2. Negative 7 and positive 5, right? And then we use these factors as, or use those numbers as our factors. V minus 7 times V plus 5 is equal to 0. Okay? This equation, now we're going to stop there. We're not going to solve. It doesn't say solve. It just says derive an equivalent equation. This equation and the original are the exact same equation. I just grouped them differently. Just like the first time I grouped the students, I said all the boys on one side, all the girls on the other side, right? Over here I took the factors, common factors, and factored by X box, okay? So that is an equivalent form, okay? Watch me do number 2. I'm going to start with the same equation, but this time I'm going to use complete the square. So I've taught you these before. To complete the square, you need to add 36 to both sides first. So you put all the constants on the opposite side, and then you write v squared minus 2v. Leave a little space to complete the square is equal to 36. Then we take half of 2v, or half of negative 2, which is negative 1, and we square it. We add 1 here, and we're going to add 1 here. Is that right? Yeah, that's right. Plus 1 here. Did I do that correctly?
Yeah.
Oh, why did I get 36?
Yeah,
I went a little too fast. I was like 3 steps ahead of the game. You'll see where I got 36 from. That's funny. Haha. My mind is going crazy. No, it's because I was 5 steps ahead. So I'm going to add 35 over, you'll see 36 in a moment. V squared minus 2v is equal to 35. And then I'm going to take half of negative 2, which is negative 1, and we're going to square it, which is going to be positive 1, right? So we're going to add 1 here and add 1 here. What's 35 plus 36, everyone? Or 35 plus 1? 36. Whoa, okay. Still ahead of my mind right now. And then this left side, remember this is a perfect square trinomial, so this is like saying v minus 1 squared. Okay? This is an equivalent form, just like the original problem, okay? So this is an equivalent form, and so is this, of this, right? This is equal to this, and this is equal to that, okay? Equivalent, equal. You hear how similar those words are? Equivalent, equal. You guys get that? So that's all we're doing. We're just saying we're regrouping the numbers in different ways. So this means the same thing as that equation or the original equation. Okay, that's all you're going to do today. Does that make sense?
Yeah.
So we're get part of this. You should already know how to Xbox. You should already know how to do complete the square. All right, so let's have 1 solid 2's on number 1. How do we get an equivalent form by using Xbox? And then 2's tell 1's, how do we get an equivalent form by using complete the square? Ready, set, and go. Okay, here we go. Number 3, derive an equivalent equation. On number 3, let's we're going to do it both ways, okay? So we're going to do Xbox, and then we're going to do the same thing for... So I'm going to hide number 4. So the first time, let's go through it as Xbox. Okay, so let's draw an Xbox together like so. So on each of your problems, this is how you're going to do it. The first time you're going to draw an Xbox. What's A equal to? No.
Art.
No, not art.
R2.
No. What's the number? 1, thank you. What's A times C? Shh, guys, we're done talking. Good, 48. And what's B? Good. What times what's going to equal to positive 48 but equals to negative 14? Good, negative 6, negative 8. Good. Okay. So you have to think hard again. And of course we boxed these like before. Can we simplify the fractions? No. So now we're just going to rewrite this as r minus 6 times r minus 8 is all equal to 0. Okay. That's an equivalent form. We're done. Okay. We're not going to solve this, but this is the equivalent form, meaning this original equation, or this equation, is equal to the original. Same thing, just a different way to write it, right? Okay, now let's do it one more time on the side. We're not done with this problem. You're going to do the same thing, rewrite it, r squared minus 14r plus 48 is equal to 0. And then we're going to, on this example, we're going to, what we're going to do is complete the square. So when we complete the square, we move c over first, so we're going to subtract 48. We have r squared minus 14r. Leave a little space to complete the square, minus 48. Okay? Now, how do we complete the square? What's the middle term? What's b? Negative 14. What's half of negative 14? Negative 7. Negative 7 squared is? Good, so we're going to add 49 here, and then we're going to add 49 here. Okay, this left side becomes a perfect square trinomial. Square root of r squared is r. Half of negative 14 is negative 7, and then we're going to square it. Okay, on the right side, what's negative 48 plus 49? 1. That's it. We're done. We're not going to finish solving this. We are all done. Okay? This is an equivalent form of their first equation. Does that make sense? Okay, so that's how you do one problem. Okay? You're going to do it 2 different ways. So, by the way, these 2 answers we got and the original problem, these are 3 ways to write the same equation. This is a way we could have written it, this is a way, and this is a way. These all mean the same thing. Just like when we had the 6 students up here, I had them up here randomly, I also had them organized by gender, and I also had them organized by hair length. Does that make sense? Okay. Question, someone has their hand raised. Okay, let's do number 4. This one you're going to do by yourself. Okay, I'm hiding number 3. So I want to see 2 other equations. Go. K minus 5 what?
Times K plus 4.
Times K plus 4
Equals 0.
equals 0. Good, that's one of them. What's the second one? Someone else. Shh. K what?
Oh, I don't know. I was just talking to myself.
K,
Squared.
no, minus 1 squared is equal to negative.
Would be 19.
No.
Equals 2.
Equals rad 21. Let's see. Let's do that. Complete the square together. Just so you guys know.
21, I
Yeah, it's
believe,
21.
because I got it right the first time.
Yeah, equals 21. Yep.
Can you show me how you did the second one?
Yeah, I'll do that right now. So I'll do that right underneath. K squared minus K minus 20 is equal to 0. So you want to add 20 first. So you're going to add 20.
Added 20.
Did you do this part? Add
Yeah.
20? Okay, then you're going to have K squared minus K
Nothing.
is equal to 20. And then we take half of the middle term. What's half of... Oh, that's why it was a little bit more difficult. I see.
Oh, I did that wrong.
Just put a 1 there.
This was a more advanced one. So, this one you'll learn how to do in Algebra 2, but the way you do this, what's half of negative 1?
0.5.
0.5 squared is 0.25. Believe it or not, okay? So when we're going to add 0.25 here, and add 0.25 here. Don't worry, you're not going to, if there's a problem like this tonight where you can't figure it out, then you just skip over it. I at least want this first one right here. This is an important one, okay? But this concept, this is an advanced complete the square problem, so you'll do this in Algebra 2. So K minus 1/2 squared, all equal to 20.25. Okay? That's it. With the square root. So when you're done, or if you have questions, come back on the video or watch the video, okay? And you should be good. That's the only thing you're doing is making 2 forms, one by Xbox, Xbox, and then the other one is complete the square, okay? Complete the square, okay?